In this video, I'm going to show you the laws of logarithms, and then I'll show you how to apply them to different types of examples. Now, since logarithms are exponents, the laws of logarithms are related to the laws of powers. First, I'm going to introduce to you a couple of very helpful logarithmic rules. The first one uses the identity that c to the power of x is equal to c to the power of x. So if I take this expression and I'm going to rewrite it in log form, we're going to pretend that this is our base, this is our exponent, and then this is our value. So we have log, and our base is c. Our value that we log here is c to the x, and that's equal to our exponent, which is x. So this is quite helpful because we can see that if the base and the value that you log are the same number, then the answer to this log is the same as whatever the exponent is in the question. The second helpful log rule uses the identity that log x equals log x with the same base c. So in this one, what we're going to do is we're going to change this into exponential form. So we're going to take this little c as our base. This will be the exponent, and this will be the value. So we have c to the power of log x with a base of c, and that is equal to x. So this one's helpful. So if the base is the same number as the base in the log, which is raised as an exponent, then the answer to this power question is actually the value that you're logging over here. All right, so this brings us to the three laws of logarithms. So the first one is the multiplication, and we know that when we multiply powers, that we add our exponents. So this means that log x times y with a base of c is equal to log x with a base of c plus log y with a base of c, because when we multiply, we add our exponents. So using this as our example with some numbers, this would become log base 6, 2 times 3, which is log base 6, and then 6. So the answer to this is going to be 1. So 6 to the power of 1 would equal this value of 6. And you can also now use this helpful rule here. So since these are both the same, c and c, 6 and 6, our answer has to be what the exponent is raised to. In this case, we could say that it's 1. All right, the next one is division. And when we divide powers, we subtract our exponents. So this will be log x with a base of c minus log y with a base of c. Using numbers, we would say that it's log base 2, 24, divided by 3. So actually, for both of these examples here, I've actually gone from the right side of my law to the left side. And I want you to know how to change them back and forth, actually. So this is going to be log base 2, and then this will be 8. And I can actually rewrite this 8 as 2 to the power 3. And then using my first helpful rule again, the answer will be the same as my exponent since these two numbers are the same. So since 2 and 2 are the same, this has to be 3. And then the last rule is called the power law. So here we have log base c x to the power of n, and this is equal to n times log x with a base of c. So notice that this exponent here, and the value that I'm logging, n, is moved to the front, and then it multiplies the log. Now please don't get mixed up with this. So this is not equal to log base c x all to the power of n. So this is not the same thing. This n power is raising this whole log value, whereas this n power is only raising the x. So let's take a look at this example here. So I can rewrite 25 as 5 squared, and then I can rewrite 625 as 5 to the power of 4. So here I have 2 log 5 with the base 3 plus 4 times log 5 with the base 3. Now, since both of these parts here are identical, we can add these 2 logs together. So you have 2 plus 4, which is 6 log 5 with a base of 3. So very, very important note. You can only add logs, like in this last example here, if they have the same base and value that it logs. So notice that these are both log 5 with a base of 3, so we can add these 2 together. Now for this last question, we didn't have to do this. We could have multiplied this first, 25 times 625, but that would give us a really big number. So in this case, it was actually easier to rewrite the 25 and 625 with a base of 5 and then move the exponent as a coefficient and then add the 2 logs together. So now we're going to take a look at some other types of examples. So in this first one here, I want you to write each expression in terms of individual logarithms of x, y, and z, if there is a z. So we're actually just using the laws to see if we can expand these questions here. So in this first one here, we can see that x is divided by y, which means that we are going to subtract our exponents. So this will be log x with a base of 6 minus log y with a base of 6. Okay, in the second one, we do have a square root. Do you see that? So we're going to rewrite this as log base 5 xy, or x times y to the power of a half. And then I'm going to rewrite this again to distribute that half so that both the x and the y get the half. Now I'm going to put brackets, it's really important here, so that I know that both the x and the y are being logged as is multiplied. So I can see that this is multiplication. So I am going to separate them with addition. And then I am going to bring the exponent to the front as a coefficient. So I have half times log x with the base 5 plus half times log y, also a base of 5. All right, the next 2 examples I'm going to show you are ones where I want you to evaluate. So the 2 that I just did, it didn't have any numbers. Where the value that I was logging were variables. So in this one here, the values that I'm going to log are actual numbers. So we're going to apply the laws to combine these together. And I could have done what I did in the last one, so we'll take a look at it in a different way. This time we'll actually use our laws instead of trying to simplify first. So 32 times 2 is going to be what we do first. Since I'm adding the logs, that means I have to multiply the values. So this gives me a log base 4, 64. So again, I get base 4. 64 is 4 cubed. Since the base and the value that I log are both the same, my answer is just the exponent of 3. In the second one, I am subtracting the logs. So therefore, the values must be divided. So it's going to be 500 divided by 4, which is equal to 125. And then 125 can be rewritten as 5 cubed. So very important that we know our powers. Probably I would recommend you know them up to 5, and then 5 cubed, and even 5 to the power of 4. So again, the base and the value we log are the same. So this answer is 3 again. Okay, now this one we have a whole bunch of coefficients in the front. So what we're going to do is we're going to move that to be the exponent. So that would be 625 to the half plus log 2 to the 4, and then minus log 4. So half means that we're going to square square root the 625 to give us log 25 plus log 16 minus log 4. So this will give me 25 times 16, and I have a minus log 4, so that means I'm going to divide by 4. So this cancels off to 1. 4 goes in 16 4 times, so 25 times 4 is 100. So we have log 100, and there's no base written down, so the base is 10. So we have to think of 10 to what power will give me 100. In this case, it will be 2.